Okay, so it's geometry exercise 4.4. Question number 1. The length of the tangent to a circle from a point P, which is 25 centimeter away from the center, is 24 centimeter. What is the radius of the circle? So it's they said it's 25 centimeter away from the center, which means from O to P it's 25 centimeter. And 24 centimeter is this distance, the tangent distance. So the question is, what is the radius of the circle? They're asking about this distance. So you'll be able to notice a right angle triangle over here. So you can apply Pythagoras in this. So if you apply Pythagoras, it's going to be opposite square plus adjacent square is equal to hypotenuse the whole square. So this side lies opposite to the 90 degree. So this is going to be your hypotenuse.
So for such sums, we need to assume a right angle triangle, then use Pythagoras theorem.
Yeah. So you just use Pythagoras theorem and solve it. So it's going to be r square is equal to 625 minus 576. So r square is 49. Take a square root, you will get the radius value. That's it. So here also I have mentioned. You have triangle LMN is a right angled triangle with angle L equal to 90. So here you have 90 degree. So there is a circle inscribed in it. The length of the sides containing right angle are 6 centimeter and 8 centimeter. So you have 6 centimeter and 8 centimeter. Find the radius of the circle, which means you need to find this or OB, OA, OC, all are radius only, anything is fine. So here also we are going to use Pythagoras theorem. We are going to use the area concept here. Area of triangle LMN is equal to area of OLM, area of OMN, and area of ONN. Sorry. So they are just segregating this into several triangles. So area of OLM. What is OLM? This is OLM. Area of OMN. This triangle is OMN. Area of ONL. They are not right angle triangles, just a triangle. Area of ONL. I mean, this. So we'll be able to notice 3 triangles inside a single triangle. So now we are saying that sum of these 3 triangles form the bigger triangle LMN, which means the right angle triangle LMN. So we are just trying to equate them. You know the formula for the area of the triangle already. What is it? It's half into base into height. Yeah. So we are going to apply the same formula thrice on this. We are going to apply the formula on this triangle, and this triangle as well. Okay. So if you do that, so let me apply it on the green one first. If I do that, it's going to be half into LM into R. So LM, I can assume this LM as base. And height is nothing but the perpendicular height, the perpendicular distance, isn't it? So you have to take this as height, the R as height. So you will replace H as height in this. So we are done with this OLM. And moving on to OMN, the black one. So if you see the black one again, this MN is going to be the base. And you have this as the perpendicular height, which is also the radius R. So just replace height as R in this. Okay. And now we'll move to the blue one. In the blue one triangle, the LN is the base. And this is going to be your height. That is nothing but radius. Okay, so you're just applying the same formula thrice and you are adding up everything and you are equating it to the right angle triangle LMN. And if you apply area formula on this LMN, this LN going to be your base and this LM is going to be your height. So which is why you have half into LM into LN. The value of LM and LN already given in the question, which is 6 and 8. So that you can directly substitute here. Okay. And you can find the value of Mn also by using the Pythagoras theorem. So you can say the hypotenuse d whole square is equal to 6 square plus 8 square. Okay. So which is 64 and 36 will give you the result as 100. If you take square root, you will get the value of Mn as 10. So the value of Mn is 10. So just replace the value of Mn is 10 in the right hand side as well. You have Mn here. Just substitute Mn as 10. And you have Lm. The value of Lm is nothing but 6. So just replace this as 6. And you have NL. What is NL? NL is Ln, which is 8. So substitute 8 here. So if you solve this, you'll be getting all the answer in terms of R. That's what we are going to find. So just simplify this. We'll get 3R, 5R, 4R. If you add everything together, we'll get the answer as 12R. So 12R is equal to 24. So R is equal to 24 upon 12, which is 2. So 2 centimeters is the result for the radius. Can you follow this question?
Yeah.
Okay. So again, same kind of question, but here it's a triangle ABC. It's not a right angle triangle. So there is a circle inscribed inside a triangle. They gave a detail about it. It's ABC triangle. The sides are 8 centimeter, 10 centimeter, and 12 centimeter. We need to find what is AD from here to here, and BE from here to here, and CF from here to here. So from this we can say, from this theorem, I guess you have already heard, like when you have a circle and 2 tangent line external to the circle. Assume this is A, B, C. We can say AB is equal to AC. Tangent theorem. Are you aware of this?
Yeah.
Okay. So we are going to apply the same theorem on this. So you have circle. So you have 2 lines. So from this we can say AD is equal to AF. So this is tangents drawn from a external point to a circle are equal. That is the theorem. So we don't know that value of AD and AF yet. So we can assume it as a variable X here. And similarly, you have BD and BE. And from this side, you have CF and CE. Okay. So let's say BD, BE are equal to Y and CE and CF are equal to Z. So we can rewrite this. We know the value of AB, which is 12, and we can also write AB as sum of AD and DB. So AB is 12. We know the value of AD, which is X. We know the value of DB. DB, BD both are same, Y. So from this we can say 12 is equal to X plus Y. And you have BC. BC can be written as BE plus EC. And you know the value of BC, which is 8, given in the question already. And for BE, it's Y, and for EC, it's Z. Similarly, you apply the same strategy on this. AC can be written as AF plus FC. So it's 10 centimeter is equal to AF is X, FC is Z. So that's your equation 3. So if you add all the equations, you will have 2x, 2y, 2z is equal to 10 plus 8 plus 12, which is 30. Take out the 2 outside. You will have x plus y plus z equal to 30. So x plus y plus z is equal to 15. So x plus y plus z is equal to 15. So you can find the value of z by substituting x plus y in it. We know the value of x plus y, which is 12. So just substitute x plus y as 12 in this. So it's going to be 12 plus z equal to 15. So from that we can say the value of z is 3. So apply the same strategy for the rest of the equation for finding the value of x, y, z. It's just a simple algebra elimination method. So you'll be able to find the value of x, y, z. And it's really simple. We already know x is AD, y is BE, and z is CF. So that's our aim. That's what we are going to find it from this question. That's it. Can you follow this?
Yeah.
Question number 4. Again, a tangent. So PQ is a tangent from a point P to a circle with a center O. QOR is the diameter of the circle such that angle POR equal to 120 degree. Find angle OPQ. So you need to find what is P. We are going to use some basic properties of triangle over here. So we can say angle POR 120 degree and angle POQ is 60 degree equal to 180 degree. It's not because of 120 and 60. You would be able to see a straight line here. Straight angle contains 180 degree, isn't it? So you can say POR plus POQ is equal to 180. So you'll be able to find the value of POQ by substituting in this. POR is already given in the question, which is 120. So just subtract that 120 from 180, we'll get the answer as 60. So POQ is 60. Okay. And what about OQP? This part. So OQP, you need to find what is Q. OPQ, if you notice, here you do have a right angle triangle. I mean, you have right angle here. So the Q is 90 degree here. And you can say angle O, angle Q, and angle P is equal to 180. We know this property as well. Sum of all the three angles inside a triangle is equal to 180 degree. So you are just taking this triangle and you are adding all the angles to 180 degree. So let's substitute the known values here. You know POQ, which is 60. You can substitute that. You know OPQ. Okay, OPQ we need to find. We are not sure about it. Just write OPQ as OPQ itself. And PQO. What is Q? Q is 90 degree here. So just substitute 90 over the PQO. So now it's going to be 90 plus 60, which is 150. For finding OPQ, we just have to subtract that 150 from 180. So we'll get the answer as 30. Can you follow this question? Do you understand? Okay. Question number 5. I think this question you can try by your own. Please go through it.
Yeah, I got 130 degrees.
Yeah, it's correct. We'll move on to the next question. Question number 6. In a figure, O is the center of the circle with radius 5 centimeter. T is a point such that OT is 13 centimeter and OT intersects the circle E. If AB is the tangent to the circle at E, find the length of AB. Let me explain the diagram. So you have a circle. The center of the circle is A. They said the radius is 5 centimeter. Let's name this point as P. They said T is an external point. So from the center of the circle to the point 3 to the point T, it is 13 centimeter distance. And they are also saying this OT intersects the circle at E. So intersects the circle at E in the sense, for the first time it meets here. So you can name this as the point E. And AB is the tangent to the circle at E. So definitely the tangent line should pass through the E. So AB is the tangent to the circle at E in the sense, the tangent line always will touch the circle at one single point. So that single point is going to be E here. Okay. So that's E. So now they're asking us to find this length, the length of AB. Do you understand the diagram? Hello. Okay. Okay. So you take a triangle OPT. You can see the triangle OPT here. So from this, they already told the radius is OP, which is 5 centimeter. And OT is also already given in the question, which is 13 centimeter. And we need to find the value of PT by applying the Pythagoras. So you'll be able to notice a right angle triangle over here. So you can write PT the whole square is equal to OP square plus OT square. So PT square is equal to OP square is 5 square and OT square is 13 square. So it's going to be 25 plus 169, which is 140. Am I? Oh, I'm sorry. I'm sorry. It's my bad. I wrote the theorem. So you have 90 degree over here. So you have 90 degree over here means this OT is going to be your hypotenuse. So this is going to be your hypotenuse, and you have the Pythagoras theorem. Hypotenuse the whole square is equal to opposite square plus adjacent square. And you know what is hypotenuse is OT square. So opposite square can be OP square plus PT square. And we know the value of OT already, which is 13 given in the question. And they gave OP also, which is 5. So for finding the PT, you just have to subtract this 25 from 169. So it's going to be 144. Take a square root on this. So PT is equal to 12. So PT is 12. You take triangle OPA. We're talking about this triangle. So again, you can apply Pythagoras in this. You take triangle OAE. Talking about this triangle, you can again apply hypotenuse in this. We'll get equation 1 and 2. So in both the equations, you do have OA square and OA square. You can equate them. If you equate, you will get OP square plus AP square equal to OE square plus AE square. OP and OE are same because both are radius of the circle. So OP and OE are same. Just a second, so just come back. Someone is. Sorry. So from that we can say OP is equal to OE. If OP and OE are equal, we can cancel the OP square and OE square. So we'll be having AP equal to AP square equal to AE square. So you can write AP is equal to AE also from that. If you apply square root on both the sides. So AP is equal to AE. AP is equal to AE. You do have same kind of diagram in the opposite side. You have BQ and BE. So this BQ and AP are parallel to each other. So we can say BQ and EB are equal. This part of the diagram is symmetry to this part as well. If AE and AP are equal, we can also say BQ is equal to BE. It's like a reflection. So you just apply this theorem again on AET. What is AET? Again, the Pythagoras. So this is going to be your hypotenuse. So AT square is equal to AE square plus ET square. Okay. So ET square can be written as AT square minus AE square. Here they have applied this algebraic identity A square minus B square, which can be expressed as A plus B into A minus B. Just substitute that. If you do that, they're saying AE and AP are equal. So just replace your AE in this part as AP. Okay. So why? What is AT plus AP? Just check what is AT plus AP. AT plus AP. AT plus AP can be written as PT. You know the value of PT already, which is 12 centimeter. We can use that over there. So just replace this AT plus AP as 12 in this and write this AT minus AE as it is. You know the value of ET, which is 8. So it's going to be 8 into 8. If you simplify this, AT minus AE is going to be 64 upon 12, which is 16 by 3. So AT plus AE is equal to, yeah, you can substitute AE as AP again because AE is equal to AP. We already learned that. Again, you can replace this AT plus AP as PT here. So that will become 12. So assume this AT minus AE as equation 1 or 2, like 3. AT plus AE is 12, which can be written as AT plus AP equal to 12. This is equation 4. So if you solve this equation, if you subtract this equation, you'll be able to cancel the values of AT. You can change this also as AP because AE and AP are equal. I'll do it again. So you're just adding these two equations. I'll write the equations again. AT minus AE is equal to 16 by 3. AT plus AE is equal to 12. Cancel this. 2AT is equal to 16 by 3 plus 12. So take LCM and simplify. You will be getting the answer as 26 upon 3 for AT. And for AE, how can you write AE? AE can be written as, you take this equation, AE can be written as 16 by 3 minus 80. So AE is equal to AT minus 16 by 3. We just found the value of AT, which is 26 upon 3. Substitute that. Simplify this, you will have 10 by 3 as the answer for AE. So we know this value already. We said AP is equal to AE means the parallel BQ is also equal to EB. So from that, if AE is 10, if AE is 10, the EB is also 10. So for finding the value of AB, you just have to add the AE plus AB. A, B, E here. So for finding AB, you can write AE plus EB. So 10 by 3 plus 10 by 3, which is 2 times of 10 by 3, 20 by 3. Can you follow this?
Yeah.
We'll move on to the next question. It's question number 7. In two concentric circles, a chord of length 16 centimeter of larger circle becomes a tangent to the smaller circle, whose radius is 6 centimeter. Find the radius of the larger circle. This is also a simple question. So try to draw a diagram with two concentric circles like this. So they said chord of length 16 centimeter. So chord is nothing but the biggest, what can we say? The biggest diameter. Okay. The biggest diameter of the circle. You can take this line. So that's going to be 16. So you have 8 and 8. If you divide this with the midpoint C, you keep a point on the center as O, you can create a right angle triangle by connecting CB and OB. The radius is 6 centimeter, which means OC is 6. And you know the value of CB already, which is 8 centimeter. So you can directly apply the Pythagoras theorem in this for finding the value of OB. Okay, so OB is going to be 10. This is the very important line. CA is equal to CB. This CA and CB are equal because OC is perpendicular to AB. OC is the perpendicular bisector to the line AB. So we found the radius of the smaller circle. We found the value of OB. I mean, not for the smaller circle. We found it for the larger one. So this is the larger one. So we found the answer for the larger circle itself. That's it. Can you follow this? Question number 8. Just try to go through the question number 8. In the question number 8 also, again and again they'll be using the right angle, the Pythagoras theorem only in this. The diagram might look bit confusing, but it is really, really easy. Try to go through the solution and let me know if you are not able to understand. Excuse me.
Step after y is equal to 3.2.
3.2. Yeah. What about x?
So we need to substitute that.
Yeah.
We'll get 4.8 centimeter.
You're getting 4.8? Yes. Okay, concurrent triangle. Show that the angle bisector of triangle are concurrent. So you have a triangle here, the triangle ABC, and the O as the point. You have the perpendicular bisector AD, which divides the BC into two equal half. The first part is BD and the second part is DC. BD and DC are equal. Okay. And similarly, you do have other lines as well. Have PE, which also passes through O. And of course, you can draw another line over here, but they didn't mention, it's not required. So this line also passes through the point O. So they're taking the triangle and they're saying that AD and BE are two angle bisectors. So you're taking two angle bisectors here. So angle bisector means it divides the angle into two equal halves. In case if you're having 60 degree as the angle B, when you divide the angle with the angle bisector, you will have 30 degree for the first half and 30 degree for the next half. That's what angle bisectors are. So these two angle bisectors meet at the point O. So what do we have to prove here? We have to prove AC upon CD is equal to OA upon OD. So we are constructing this line CO. This line CO also intersect at the point O here. So take a triangle. You can divide this triangle into ABE by taking a smaller part of this. So if you take this, you would be having AB upon AE is equal to OB upon OE. This is what angle bisector theorem. This is how they will take. So imagine you're having a triangle. They'll take the larger part of the side. They'll take the largest side and they'll write the first part as the numerator and the second part as the denominator. Okay. So you take the other two sides of the triangle. For example, AB and AE. So you write one as the numerator and the other part as the denominator. That's what angle bisector theorem says. Can you follow this?
Yeah.
Similarly, AB by AC is equal to BD upon DC. You can write like this also. So from this, part, you can write AB by BD is equal to AC by DC. You can interchange their position. You can write it like this. So if you take triangle ABD, if you take this triangle, AB by BD is equal to AO by OD. Again, you are applying the angle bisector theorem on this. Okay. So now you have AB by BD from the triangle ABE and triangle ABD as well. So you can compare these two equations. If you compare these two equations, you can write AC by DC is equal to AO by OD. Can you follow this? So AC by DC is equal to AO by OD. So that's what our aim. We have proven that. Question number 10. So in the question number 10, you have triangle ABC with angle B equal to 90 degree, which means it is correct.
Question, I don't think it's actually there.
It's not
The
there.
10th question for me is an artist has created a triangular stained glass window. That question.
Is this one?
Yeah.
Okay. Okay. An artist has created a triangular what is it? Oh, stained glass. Okay. An artist has created a triangular stained glass window and has one strip of small length left before completing the window. She needs to figure out the length of left out portion based on the length of other sides as shown in the figure. This is the given figure. So what they're asking, one strip of small length left before completing the window. Okay. Which means she didn't stain that part. The diagram is not clear. Okay. Excess. Which part we need to find? AF. Actually, this is AF. It looks like it is stained already. Do you have the same diagram in your textbook as well? Is this part stained?
Yeah.
Because they're asking us to find the length of the left out portion. Left out means it shouldn't be stained. I don't understand why they are finding AF. I think it's BF. You have a printing mistake here. Sorry. It's BF actually. That's what I'm wondering. It's a printing mistake. Okay. So here, this is the left out portion. So she needs to figure out this length only. She needs to figure out the length BF, which is X. Okay. So let's apply angle bisector theorem on this. So they are taking O as the concurrent point. So concurrent point in the sense where all the angle bisector lines meet at this point. You can assume this point as O. So the concurrent lines are CF, AD, and EB. So these three lines are passes through the point O. So if you apply angle bisector theorem on this, it's going to be BF upon FA is equal to, you have O here, OB upon OA. So they are taking the triangle, they are taking this triangle AB, OAB. So they are taking this triangle and they are applying the angle bisector theorem on this. You are getting this equation. And when you take this triangle, it would be CD upon DB is equal to OC upon OB. And now you're taking this triangle AE by AC is equal to OA upon OC. Can you follow this?
Yeah.
So now we are multiplying all the three. We are multiplying all the three and we are substituting the values in it. So when you multiply this OA, OC, OB, and OB got cancelled, the right hand side has become 1. Okay, in your left hand side, you have, this is BF actually. It's BF upon FA times CD upon DB times AC upon EC. So BF is X and FA is 5. CD, DB, EE, these values are already given in the question. They gave all the 5 values except the B. So just assume BF as X and simplify this. You'll be getting the answer of X as 2 centimeter. That's all about this question. Do you have any other question in the textbook on 4.4?
No.
Okay. These are all only constructions. Just a second, I'll just go through once. Okay, that's it. Do you have any other doubts in the geometry?
No.
No. Okay. So okay, so we are done with the geometry and we need to discuss coordinate geometry and trigonometry.
Yeah.
Okay.
Trigonometry also you've conducted like 2 tests, so I'm kind of okay in that.
Okay.
But only like coordinate geometry, especially the straight line, that alone I have like doubts.
Okay.
And I make mistakes in that a lot.
Okay. Okay, fine. That we can discuss in the evening. Like what time you are available in the evening?
Maybe from 4.
From 4. Okay. You would be returned by that time, by 4.
Yeah.
Okay. Okay, then we'll keep at 4. I'm fine with 5 o'clock as well. You just let me know if you reach before 4. We can keep at 4 o'clock itself.
Okay.
Okay then. Okay then, shall we stop here? Okay. Okay, you can take leave.